Now I'm coming to the proto-oncogene. As I said, SRC acting as a proto-oncogene. So what is actually proto-oncogene? So proto-oncogenes are a group of genes that actually causes the normal cell to become a cancer cell when there is any kind of mutation. This may be point mutation or other kind of mutation. So any mutation in the proto-oncogenes will typically convert the normal cell to a cancer cell. But this type of mutation is a dominant type of mutation. So proto-oncogenes actually encodes the proteins, and these proteins actually stimulate three different things. They stimulate cell division, they inhibit cell differentiation, and also they restrict the cell death, means immortalization of the cell. So they can also code for some intracellular proteins that normally act as a downstream of the cell surface receptor pathways to stimulate cell growth and division. Now, there are some examples of downstream signaling proteins, which includes HRAS, KRAS, RAS, HER2, M1C, that is actually present in Burkitt lymphoma, cyclin D, and so on. So what is actually the function of proto-oncogene? So these proto-oncogenes are of dominant type. So if you recall to your classical genetics, there are two types of zygote. One is a heterozygote, and another one is homozygote. Here, the heterozygotes are specified as a spherical one, which is a mutant. In case of homozygotes, sorry, both the alleles are of mutant type. So as because it's a dominant type mutation, so both the cases, heterozygote as well as homozygote, functions gained. So they always bind with the DNA and functions gained. But here you can see that the proto-oncogenes that are present there at DNA, so they are actually doing point mutation, they're amplifying this gene amplification and is responsible for normal growth stimulating protein in excess, and then for translocation and transposition normal growth, stimulating proteins in excess. So most of the cases you can see that stimulating proteins in excess. So what is actually how the proto-oncogene is converted into oncogene? So here, this is the 5' cap, this is the 3' poly tail of two different type of. First picture, this is a murine leukemia virus where three different genes get poly, NP, green, blue, and a deep green color, you can see. And the second picture, you can see the nucleic acid of sarcoma virus. Here, an extra gene is there. This is a SRC gene. This SRC gene actually a proto-oncogene. So this conversion of proto-oncogene to oncogene took place by the process called splicing. Here you can see the red spots. These are the exons. The proto-oncogene is a cluster of genes, cluster of red spots. And in between that, you can see some gray spots or gray region. These are actually the introns. So when splicing is taking place, so the introns are excised and the exons are coming all together. They are converting into a new gene, and this particular gene is known as oncogene. Now, the second type of gene that we have is an anti-oncogene, or rather you can say tumor suppression gene. So as the name suggests, this particular type of gene actually makes a protein called the tumor suppressor protein that helps to control cell growth or cell proliferation. So any kind of mutation in this tumor suppressor genes may lead to cancer. The mutations are of acquired type and they are not inherited. So two examples are there. One is RB gene, another one is P53 gene. So RB gene is actually a suppression gene, tumor suppression gene that is actually suppressing the retinoblastoma. So any kind of mutation in RB gene, so that will eventually result to retinoblastoma. In case of P53 gene, this particular gene is synthesizing the protein or encoding some protein, and those proteins are actually regulating gene repair in cell. So any kind of mutation in P53 gene, so gene repair function will be lost. So oncogene mutation is a recessive type. Proto-oncogene mutation is a dominant type, but again you can see in the heterozygote. So as because this is a recessive type mutation, so here the protein will bind and control cell cycle, but in case of most alleles are of mutant type, so here the function is lost. Means there is no binding, so there is no control of growth. So untreated growth or untreated cell proliferation will occur. So eventually they will produce tumor cell. So the anti-oncogenes or the proto-oncogenes, they are actually regulating some functions. So we can find this anti-oncogene or tumor suppressor genes uh, in, us, and this retinoblastoma gene, which is actually an anti-oncogene, and this particular gene will regulate the functions in the normal cell, and any normality or any mutation occurs in this tumor suppressor gene will uh, will reflect in retinoblastoma, lung carcinoma, breast carcinoma. So any kind of mutation in the retinoblastoma gene, you can have these three type of cancer. And this type of RNA viruses, Ross sarcoma virus, what do, so the question will come, what do this oncogene encode? So RNA tumor virus, like the Ross sarcoma virus, so this particular genes, they encode some proteins, and these proteins actually controlling the growth, cellular growth or proliferation, and cell differentiation via some protein or downstream protein synthesis. So what they are actually synthesizing? They are synthesizing some growth factor receptors, signal transduction proteins, transcription factors, and so on. So here you can see the RB gene is a 150 DNA stops replication of the gene. And when this particular protein, other kind of protein subunit that is maybe coming from the adenovirus, the protein subunit E1A coming from adenovirus. So here the function is lost. Means the RB protein will not associate, will not bind with the DNA, and then the cell cycle will continue. There's nothing will regulating the DNA to stop replication. So the cell will continue replication, the cell cycle will continue, so the cell will be immortalized. P53 is a particular type of anti-oncogene we have already discussed. So inactivated by deletion, point mutation. So any kind of mutation will change this anti-oncogene or tumor suppression gene into an oncogene, and here they will convert to the normal cell into a cancerous cell. So this is the picture of a cell cycle where you can find the different phases of the cell cycle. So the tumor suppressor genes is actually guiding the cell where to stop. But the proto-oncogene will start cell cycle and the tumor suppressor gene is making a halt. But any mutation in both the genes, proto-oncogene and tumor suppressor gene, will result genetic change that alters the expression or the function of the protein that plays a critical role. What are the critical roles? The critical roles are cell proliferation control, cell differentiation initiation, and control or halt of cell cycle in cell division. So any kind of mutation of these two genes, actually they are causing the normal cell, or the normal cell is becoming to a cancerous cell. So all the functions will be lost. And oncogenic viruses causing cancer by inducing changes in these two genes affect cell growth and division. So here the second gene, that is the p53 gene, first gene we have already discussed. The first step p53 gene, this is a normal function. It binds with the DNA and stops replication. And when hepatitis C protein subunit binds with the p53 gene, tumor suppressor gene, or papillomavirus, that is actually coming and binding with the tumor suppressor gene. In both the cases, the function of p53 gene will be lost. Hence, replication will continue, cell proliferation will continue, and the normal cell is becoming into a cancer cell.